Welcome to this video on finite differences. By the end of this video, you will be able to derive finite difference formula for higher derivatives. So up till now, we've only looked at the first derivative. But what do we do about higher derivatives? So for example, what do we do if we want to calculate the second derivative of the function f at the point xi? Well, we're going to use Taylor series again. So let me write the Taylor series for the point xi. Well, for the point to the left, xi minus 1, around the point xi. So I have f of xi minus 1 is f of xi minus h times f prime plus a half h square f double prime xi minus 1/6 h cube f triple prime xi plus 1 over 24 h to the power 4 times the fourth derivative of f at xi plus infinitely many additional terms. And now let me write the Taylor series to the right for f of xi plus 1. That would be f of xi plus h times f prime xi plus a half h square f double prime xi plus 1/6 h cube f triple prime xi plus 1 over 24 h to the power 4 times the fourth derivative of f at xi plus infinitely many additional terms. Now, we want to calculate f double prime. And we don't know f prime, right? So we have to get rid somehow of the f prime term. Because the only thing we know are the f values, the function values at those points. But we don't know f prime. So we have to get rid, we have to eliminate these f prime terms. So how? Well, by finding a combination of these two Taylor series to get rid of the f prime term. And that's pretty straightforward, right? The first equation has a minus h times f prime. The second equation has a plus h times f prime. So here we can directly see what the combination would be to get rid of the f prime terms. We just have to add the two Taylor series together. So let's do this. On the left, we have f of xi minus 1 plus f of xi plus 1. And then on the right, we have f of xi plus f of xi. That's 2f of xi. Then these are the f prime terms that will cancel away. And then we have as the next term over a half h squared times f double prime. We have that twice. So that would be h squared times f double prime. And then we have minus a 6h cubed plus a 6h cubed times f triple prime. So if we add these two together, then these terms drop out as well. And then the next term over is 1 over 24 times h to the power 4, and that appears twice, so it is 1 over 12 times h to the power 4 times the fourth derivative, plus infinitely many terms. Now let's solve this for the second derivative, f double prime. So we have f double prime is equal to, well, we're going to divide everything by h squared. Okay, and what do we have left? Well, we have f of xi plus 1 on this side. Then we're going to move the 2f xi over, so minus 2 times f of xi plus the f of xi minus 1. And then we have these truncation error terms, which are h to the power 4 divided by h squared. So that leaves me with order terms that are h squared. Okay, so that's my finite difference formula, which is second order because the truncation errors are proportional to h squared. Now, what do we do, though, for the very first and the very last data point? Because this particular formula uses a value to the left and to the right. Well, we would have to do Taylor series for xi plus 1, xi plus 2, and do the appropriate combination. And do Taylor series for xi minus 1, and xi minus 2, and do the appropriate combinations. So in the first case, for the first point with points only to the right of it, that gives me here the formula that is shown. And if I do this, I will find that this, unfortunately, is only first order accurate. And if I use only points to the right of my point xi, I will again only find a first order formula that is shown here. If I wanted to have a second order formula, I would have to add now an additional point to the left or to the right. Now, the strategy for any higher derivative is basically this. You write the Taylor series for points that you want to have in the formula. And then you find linear combinations of these Taylor series that eliminate all the lower derivatives. And if it's still possible, meaning you have still additional Taylor series available, then find linear combinations that eliminate lower powers of h from the Taylor series to improve the truncation order of the method. Now in the textbook, in table 8.1, you will find a large table that contains finite difference formulas for the first derivative, the second derivative, the third derivative, and the fourth derivative formula. So either please refer to this slide here or refer to the textbook in table 8.1 that contains all of these individual finite difference formulas that follow this exact strategy here to derive these formulas for first, second, third, and fourth derivative. Thank you for watching.